Nature has no secrets, only great truths that it readily shows to all who will look. Someone somewhere knows all these great truths, but no one individual knows all of them. Academia's role is to select from among those who know that set of known things that most likely represent reality. So when we say we just don't know, we really mean that academia has not yet selected from among the many competing theories that set of ideas that explains the unknown subject. The slow pace of academia's selections keeps us from accepting wrong ideas in theory, but academia has a very poor track record. In all of recorded history, academia selected the unreal over the real almost every time. For example, academia chose the Earth-centered solar system model of Aristotle and Ptolemy over that of astronomer Aristarchus of Samos, Greece, who proposed a sun-centered system almost identical to that of Copernicus. We only know of the Aristarchus proposal because Archimedes described it in his book The Sand Reckoner. Archimedes liked the unreal Ptolemy model because it fit the religious views of the time. It was blasphemy to suggest that the Earth was not the center of the universe. A sun-centered solar system was gradually and grudgingly accepted after Copernicus showed the mathematical beauty of it. Published just before his death in 1543, his ideas were immediately trashed and ridiculed by academia. Hundreds of such examples abound throughout history. That brings us to the point of this set of thoughts. Among the most sacred ideas entrenched in academia today are those of quantum theory. Scholars even suggest that Einstein and Schrödinger were senile because they did not accept quantum theory. Philosophers said from the beginning that quantum theory was philosophically unsound at its foundation. They said this because quantum theory did not meet philosophical tests for reality. It now is blasphemy to suggest that quantum theory may not represent reality. However, that is exactly what we are going to suggest. When we look back, we find that philosophical reality and accepted theory converge at about the turn of the 20th century. At that time, the prevailing notion about physical reality was that the electromagnetic field comprised all of it. Physicists of the time formulated a set of equations based upon that notion. This set of equations, known as the Lorentz transformation, still predicts all of reality phenomena. Nothing observed in nature rules out the notion that electromagnetic activity accounts for all of it. However, the notion that the final irreducible constituent of all physical reality is the electromagnetic field is not compatible with quantum theory. It seems that when reality does not agree with quantum theory, academia suspects that reality is wrong. We each can develop our own unique understanding of the way the universe works by choosing ideas from among renowned physicists. We'll do that now. The rules are simple. We start at the place where philosophical reality and accepted theory converged. We inspect ideas that developed from that time in the past to the present. We select from among renowned physicists ideas that bring back causality and philosophically sound notions to the description of reality. Soon after the turn of the 20th century, several theories attempted to explain relativity phenomena. We join Dr. Albert Geis and accept as real the Lorentz version of reality. In doing so, we must reject Einstein's version. Einstein's notion that inertial frames of reference were reciprocal allowed paradoxes such as the twins paradox, where each twin sees the other age more than himself. The Lorentz version of relativity avoids this by providing a special inertial frame that is at rest in space. All phenomena is relative to that special frame. Academia still prefers the Einstein version. We accept as real the notion of gravity as explained by Sir Arthur Eddington in 1920. Eddington surmised that the path of light must always bend toward the direction where the speed of light is slower. Comprised of light, material objects must migrate toward that same direction. Current-day physicist Dr. Albert Geis of Germany independently arrived at that same notion about gravity. Dr. Geis shows with mathematical certainty why it is that the path of light bends twice as much as the path of material objects, as each passes a gravity source. Other notions about gravity do not explain this. Academia does not yet accept this great truth. Two constants of empty space determine the speed of light in a perfect vacuum. However, there is no place where a perfect vacuum exists. The presence of electromagnetic activity alters the two constants such that the greater the activity, the greater the constants, and the slower the speed of light. Maxwell's equations relate the speed of light to electric permittivity and magnetic permeability such that the speed of light equals 1 divided by the square root of the product of the two constants. In a universe where all things consist of electromagnetic activity, material objects radiate massive amounts of invisible electric and magnetic fields. Sir Arthur Eddington provided another great notion at a time when it was not possible to test it. That notion was that starlight must warm space debris and provide a blackbody radiation temperature of about 3.18 Kelvin. This is close to the measured value of the cosmic microwave background radiation of about 2.725 Kelvin. So we accept Eddington's idea and reject the idea that the CMBR represents the remnants of a cooled down Big Bang. There was no Big Bang. Academia still accepts the notion of a Big Bang, even though physical laws of nature must be violated to arrive at that notion. Academia still has no clear answer to the question, what is mass? But a few physicists have known the answer since the turn of the 20th century. The great French mathematician Jules Henri Poincaré noticed that pulses of light had the property of momentum. That property was previously associated only with matter or mass. He quantified the momentum of light as equivalent to mass with an equation that stated that mass equals. Substitute the word is for the equal sign and we have the answer to the question, what is mass? It is variation in the amplitude of electric and magnetic fields. Mass is electromagnetic change. We sense that change when the change is confined to a local area. Einstein referred to this same equation as E equals mc squared in some of his work. Dr. Robert Hofstadter of Stanford received the 1961 Nobel Prize in Physics for his discovery of atomic nuclear structure. He proposed a simple shell structure for atomic nuclei. Academia has not yet accepted a shell model, and Hofstadter never developed his hypothesis further. We can propose a shell structure for elementary particles consistent with Hofstadter's work. Such a structure has atomic nuclei comprised of sandwiched shells such that each shell mass is the square of the mass of the next shell out. 4 such shells make up a neutron, and 3 make up a proton. The sum of the calculated masses fit the measured values. Dr. Hofstadter bombarded atomic nuclei with electrons of energy on the order of 200 million electron volts. He calculated a nuclear structure based upon how the electrons scattered. The scatter pattern also indicated the size of the particle from which the electrons scattered. Higher energy levels detect smaller particles and miss the subtle electromagnetic structure. The shell structure proposed here consists only of subtle electric and magnetic fields. Higher energy levels miss them completely. 1 photon comprises each shell. Its wavelength determines shell size. Based upon this, the electron must be the largest of the elementary particles. Electrons do not orbit or exist as a probability cloud around protons. The much larger electrons engulf smaller protons and neutrons. Dr. Max Planck discovered that electromagnetic radiation exists only as discrete multiples of its frequency times a small value. Known as Planck's constant, the value is expressed as ergs, or energy time. Since frequency is infinitely variable, the actual energy value is also infinitely variable. The actual energy amount depends only upon the frequency. Strangely absent is the electromagnetic amplitude of the E and B fields. Since amplitude is not part of the equations, the amplitude of the E and B fields must be constant. This constant amplitude of the E and B fields must be a fundamental constant property of space. It is the fundamental cause of the quantum nature of light.